Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Improved Energy Efficient Routing Protocol in Wireless Sensor Network. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the recent research topic that we are developing for preserving the energy of the sensors in the sensor networks and IoT based networks. As IoT is one of the trending domain for the researchers, so it is a challenge for them to preserve the energy of the sensors in the network. So before moving to the video, let's talk about that what we will cover into this video. In this video, initially we will discuss about in which application areas this sensor based technology can be implemented. Other than that, whatever the code we have designed, how to execute it, and what are the software requirements and the library requirements to execute it will be there. Then we will discuss about what are the current systems and what were the problems identified in those works, and in order to handle those problems, what is given in the proposed method. Finally, an experimental outcomes and the graphical comparison has been given, and an overview will be given to it. So let's talk about the application areas. So the proposed methodology is related to the different application areas, especially related to the healthcare monitoring, where the sensors are deployed on the patients and can be surveillance for the different parameters like BP, heart rate, and many others, when the doctor will not be able to monitor them continuously in the 24 manner. So in the healthcare monitoring platforms, this domain is very much helpful. For the smart agriculture, where the remote locations where it is not easy for the human to survive in the remote location, there the sensor based agricultures can be implemented. So pH for the water ratio, temperature, heat, UV radiations, and many other related sensors can be deployed in the field and can be remotely processed and accessed in order to get the smart agriculture. For the smart home systems, there also the sensor networks are very much popular and currently attaining so much attention from the industry purposes and the individual purposes. For the surveillance at the remote locations through the drones or the cameras, so that it can be easily processed from the remote location, the sensor based work can be there. All these application area are effective. The challenge with them is to preserve their energy and how to transfer the data from that remote location to the main station. So that is basically the challenge. So inspired from that, we have developed this system under which we are providing the strategy that how the energy of the sensors deployed in the remote locations or in the devices can be preserved for longer period, and their energy can be saved so that they can stay longer, and that will obviously a reliable solution. So how to run the code? So in order to run the code, you will get this folder in which all the files are in this particular folder. All these files are implemented in the MATLAB, so you must have the MATLAB software with you. The MATLAB version that we are using is R2019A, so you can use either 2018, 19 or upper, but make sure the version should be the higher one. It should be the full version, not the trial version. So in order to run the code, you just need to go to the folder where all the files will be there. You just need to copy the path of the folder and then go to the MATLAB and paste it here. Control V, press enter. When you will press enter, all the files will be displayed here. So this is the main code file of the scenario where the sync is not mobile. This is the scenario when sync is mobile. Very first is the manual deployment of the network. Then we have done the comparison in terms of the changing area, and then by changing the sync location, right? So we do have these 5 files with us to show the different scenarios and the proposed methodology. So to run this code, you must have the you just need to open this file and you will go to the editor window. There is a run button, you just need to click on the run and the file will be executed. As you can see, this is the one of the code in which we are deploying the sensors in the network manually. So it totally depends upon you that where you want to deploy the networks and how many sensors you want to deploy. In order to remove the functionality of static scenarios, you just need to do the manual deployment. So it can be helpful for any of the environment. So you just need to give the node count, that how many nodes you want to deploy into it, and accordingly you will be able to plot the nodes and can get the inputs. So we have run this system for multiple scenarios, so that's why it is deploying here. So after deploying all the nodes, we just save them in the terms of xy coordinates. So this is the xy coordinates where we have deployed the nodes for the different sections. So as I just running it again, you can see it has 1 2 3 4 5 sections. So it means with the node of 100 nodes, 20 each nodes in individual sections are there. That is the uniform deployment of the network, and as per the user manual deployment, so that it can be fixed to any of the scenario, any of the application area. For the dynamic nature, we have done that. So this is one of the file, right? In the second scenario, now the main code where it happens. So this is the main code where whatever the points we have deployed, the location we have deployed, they are just directly loaded and then the scenario has been implemented. Now let's run this code. If you have not saved it, just comment this point, and then I'm just running this code. Same I'm doing for this, because we need not to save it again and again. So the main file is executing, it start executing. In the meantime, let's talk about what exactly the problem is. So we have considered this paper, which was for the mobile sync support for the wireless sensor network. They have deployed two of the work in which initially the cluster head selection is given by calculating its weight. The weight is calculating by the basis of the energy consumption and the communication area they need to cover. Secondly, by the greedy algorithm, they are selecting the class better node and doing the communication within the cluster, intercluster communication. So by doing this, they are forming the clusters in the circular scenario where the nodes are deployed within the network. No grids has been formed. Secondly, for selecting the best cluster head, they were applying this residual and distance to sink strategy. Thirdly, the sink is moving and they are sending the data to the sink by this intercluster communication, right? But what problem we have identified? We identified that the parameters that it is considering for selecting the cluster head are not enough, because only residual energy and distance to sink is not enough. We need the distance among the nodes, because the cluster head chosen has to collect the data from the nodes and nodes have to send data to their cluster head. Secondly, when sink is moving, might be sink will be at the location where they need to go through a number of nodes to make a chain to send the data to the sink. So that is a challenge for it and consume more time while selecting the chain among the cluster, right? So for that, inspired from that, what we have proven, what we have done, we have made it the changes first, in which we have extended the parameters, in which one of the parameters introduced along with the remaining energy and distance to the sink is the distance among the nodes and the cluster head within the cluster. Secondly, we have proposed a strategy in which one new node has been introduced, that is termed as coordinate node. So let me show you that which exactly the coordinate node is. So here you can see this is the network. Here the sink is placed in the center, because one of the scenario is when we are not moving the sink. So we want to prove that by applying these coordinates node, even if sink is static, our network will be stable for longer period. So one of the thing is the uniform deployment of the network. Secondly, parameter for clustered selection has been improved. Thirdly, all the nodes have to send data to the coordinate nodes. These coordinates node will directly send data to the sink. These coordinate nodes are considered to be rechargeable, so there will be no effect of the energy on these nodes. So by doing this, our proposed methodology is achieving different results. So this is the analytical outcomes in terms of the dead node, alive node, energy, and a comparison with the CCMAR, which was the base paper's outcomes. So you can see even the sink is static, our system is stable for longer period. Same for the dead nodes, and even the energy consumption is less with respect to the traditional model. Now in the second scenario, what we did, we just changed the sink. We are moving the sink also. So you can see here the sink points are generated where the sink is also mobile, and every time the sink is changing its location. So when I'm running this code, you can see the sink start moving and the communication. Just wait a minute, I just made the comment here in order to close it. So I'm running it again. So when it is running, you can see it is running for number of rounds, and every time sync is also changing the location. Coordinate nodes are there. The selection of the communication node on the basis of the new parameters has been given. So in this scenario, because sync is moving, obviously it is expected that the system will not be stable for longer period, because obviously every time they need to change. So this is the sync movement during the whole communication. Coordinate nodes are there. So because of that, you can see these are the proposed results that we have achieved. But still, in our scenario, the same, our system is achieving results more than the traditional one. Even the sink is movable. So you can see the scenario is giving the better results by deploying the proposed methodology. If I'm running it again, the results will vary and will give you the different results. So by doing these stages, we just explored that what will happen if the sink will move, and if it is stable, whether it will preserve the energy or not. So it is preserving the energy. You can see the difference among the, whether it is minor one, but still it is better one. So in the both scenario, proposed method is getting the better results. Then we have compared for the different scenarios, as the base paper is having the results with the variation among the cases, like changing the location, changing the area, changing the radius. So for that we have compared for the changing the area. So let's see by changing the area what kind of results we received. I just made the comments in order to show the results. So I'm running it again. You can see the saved results has been run and graphically represented. Let's see about the results. So these were the results. Those were got for the dead nodes, alive nodes, residual energy. This was the comparison that we had made for the first scenario that I already shown. And finally we did the comparison by changing the area. So when the area is 100, 200, 300 and 400, you can see the rounds for the stability is getting increased when the area is getting increased. This is the alive nodes. This is the energy consumption. So with the less area, more energy consumption is there, because obviously their communication is very much closer to each other. And as the distance area will increase, because the collectivity and the communication strategy is effective, it is stable for longer period. So this is basically the first half and dead node comparison. First node dead, half node dead, and last node dead comparison among the variation of the area. Similarly we did with the sync mobility, that at different speeds and different communication range, how it performs. So let's see the results of it also. So these results are also for the analytical purpose. So here you can see first node dead, half node dead, and last node dead comparison by changing the communication range. So these are the curves for that. So further modifications are still possible into it. We can improve more for the mobility models and can get the better results. So for those you can contact us directly for the PhD or doctorate research, or the industrial based application where sensor deployment in the IoT network is still a challenge and the communication protocol need to be extended. So I hope you people like this video. For more such videos, stay tuned to our channel. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.